Welcome back to Aurora Tech Channel. Last December, I reviewed the Ender 3 S1, which is the most advanced Creality printer that I have ever used. It is packed with all the updated features that you can expect from a new generation 3D printer, and the print quality was also outstanding. Last week, PerGear sent me the Ender 3 S1 Pro to review. When I first looked at this printer, it looked like it was just the Ender 3 S1, except with a high temperature hot end that can print up to 300 degrees to print nylon, nylon carbon fiber, and other high temperature filament. However, it is actually much more than that. Some of the upgrades are obvious, while others are just small details. First, let's take a look at the common features between these two printers. 1. A new Creality Sprite dual gear direct drive extruder. 2. A dual Z-axis with a timing belt. 3. A 32-bit board and silent stepper drivers. 4. CR Touch auto bed leveling. 5. X and Y axis belt tensioners. 6. A filament sensor. 7. A spring steel sheet removable print surface. 8. A color screen. 9. A higher quality limit switch, a durable heated bed cable, a sturdy base, clean cable management using a ribbon cable, drawers, and full-size SD card support. Besides these common features, the Ender 3 S1 Pro has 7 major upgrades. 1. Hot end. Using a titanium heat break, the maximum nozzle temperature has increased from 260 Celsius to 300 Celsius. The hot end thermistor has also been upgraded, so this printer can now print nylon, nylon carbon fiber, polycarbonate, and other high temperature filament. 2. Extruder. The extruder body and the filament feeding lever have been upgraded from plastic to metal. 3. Screen. The color screen with knob control has been upgraded to a color touch screen. 4. Print surface. The sticker print surface on the spring steel sheet has been upgraded to textured PEI. 5. Insulation was added at the bottom of the heated bed to improve energy efficiency. 6. A LED light with an on and off switch was added at the top of the gantry. 7. A redesigned base. It changed from a sheet metal and plastic front panel with the side aluminum extrusions outside of the base to a one-piece injection mold base that wraps the aluminum extrusions inside for a better appearance. There are also 3 minor upgrades. 1. The maximum temperature of the heated bed was increased slightly from 100 Celsius to 110 Celsius, as the PEI print surface can sustain a higher temperature than the sticker. 2. A heated bed handle was added. 3. An improved drawer design with larger capacity and a handle was added for easier access. And there were 2 changes. 1. The power supply and power switch were relocated from the left side to the right side. 2. There is a new screen UI that supports 9 different languages. These are all the differences I can find so far, so let's start testing out this printer and compare some of the prints with the Ender 3 S1. We have the base, the gantry, the Sprite hot end, the 4.3-inch touchscreen, the filament holder and runout sensor, the power cord, tools, and some sample filament. I will first attach the gantry to the base. Move it to the edge of the table, insert 2 M5x45 long screws, and tighten them. Rotate it and do the same to the other side. Next, put the extruder on the X carriage plate. Use 4 M3x6mm screws to secure it. Mount the filament holder on the top of the gantry. There are no T-nuts or screws, so you just need to snap it on the T-slot. Connect the touchscreen cable and use 4 M4x18mm screws to mount the screen at the front right of the base. We can now connect some cables, starting with the filament sensor and then the Z-stepper motor on the right side. There are 2 cables taped on the gantry. They are the filament sensor and the LED light. then the Z stepper motor on the left. Grab the ribbon cable and the two small connectors in the middle. The wider one is for the X stepper motor and the other one is for the X limit switch. Connect the end of the ribbon cable to the hot end assembly and secure it. There is a label on the screen protector that reminds you to check the voltage at the back before connecting the power. As you can see, it was set to 230 volts by default. As I'm in the US, I will just flip it to 115 volts. Now the assembly is done. We can connect the power and turn it on. I will do auto home to make sure the stepper motors, limit switches, and the CR touch sensor are all working. Select ready and you can home X and Y or home Z. In fact, if you select home Z first without homing X and Y, it will just do all three axes together. Next, I will set the Z offset. To do that, we need to go to Settings, Level, select AUX level, and this will bring up the manual corner level menu and the Z offset adjustment buttons. Let's move the nozzle down to the bed. Negative 3.15 millimeters is slightly scratching the paper, so I will keep this value. Then go to the center and the corners of the bed and adjust the knob underneath to level all four corners. We want to keep the bed as level as possible before doing auto bed leveling. Okay, click Auto Level at the bottom of the screen and then press Start. The CR Touch will probe 16 points on the bed. Okay, we can preheat the bed and nozzle. Once the temperature of the nozzle reaches 200 degrees, we can feed in some filament. Just press down on the lever to release the spring pressure and push the filament in. Let's go to the computer and set up this printer. You can install the older version of Cura in the SD card that came with the printer profile, but I will just add this printer to my own Cura. Select Add Printer, and since this printer profile is not available in the latest Cura, I will just select Ender 3 Pro and change the name to S1 Pro. We also need to change the maximum Z height to 270 millimeters. The retraction settings are the same as Ender 3 S1, so a distance of 0.8 and 35 millimeters per second should be fine. Let's start with a simple calibration cube to make sure everything is working. The layers and surfaces all look good even when I zoom in very close. Let's print another one with the Ender 3 S1 and compare them. These two cubes may look slightly different depending on the light reflection angle, but I would say they are pretty much identical. Next, I will print a 3D Benchy on both printers to compare. I will also use a power meter to check the power consumption, as the Ender 3 S1 Pro has insulation under the heated bed, so I want to see how much energy it can save. It consumed 0.179 kilowatt hour, which is 179 watt hour. The Ender 3 S1 consumed 203 watt hour, so the insulation really can save some power. Let's compare the results. They are also identical and they both look super nice. Then I will try a tough print, the Eiffel Tower. Let's resize it to 270 millimeters so we can use the maximum height of this printer. I have used the Ender 3 S1 to print the same model before and it looked great. So let's see how this Ender 3 S1 Pro prints and compare the two. Okay, The print quality comparison ends here, as these two are essentially identical. I will just keep the focus on the Ender 3 S1 Pro and test out different materials. I will try some PETG filament to print a phone booth. I will change the nozzle to 235 degrees and the bed to 85 degrees. I'll also set the maximum cooling fan speed to 40%. The PETG foam booth is also printed very nicely. Next, I will try some ABS filament to print a set of shelf brackets. I will change the nozzle temperature to 255 degrees and the bed to 110 degrees. It looks like this textured PEI sheet sticks ABS really well. I can just print ABS directly on it without applying glue. The bottom sticks well during the whole print. There's no warping, no issues, and the print quality is good as well. Next, I will try some high temperature filament. I will print this set of phone mounts. There are 3 parts: the main body, the knob, and the top. First, I will use nylon to print the main body. The nylon filament I'm using is based on a copolymer of nylon 6 and nylon 6.6. I actually printed it at 260 degrees with a slower speed, but the best result I got was at 280 degrees, so I will set the nozzle temperature to 280 and the bed to 60. Cooling should be off. I also put this roll of nylon filament in this dryer. Generally, nylon requires a higher temperature of around 80 to 90 degrees to dry, but most affordable dryers between $50 to $100 in the market are designed for PLA, PETG, or ABS, making them unable to reach this high temperature. So, I just used the maximum temperature of this machine, which is 50 degrees, and dried it for 12 hours. This long piece of the nylon part sticks pretty well on this print surface. The first layer looks good, and it sticks well during the whole print. As you can see, there is no warping on all of the corners. The texture at the back also looks nice, as the threads are all clean and sharp. Next, I will try to print the knob with nylon glass fiber filament. It's harder than nylon, and the temperature has to be set to 300 degrees for a good result. I will keep the other settings unchanged, dry it with the same filament dryer for 12 hours, and start this print. The result seems okay, but there's a little bit of burned filament residue from the nozzle on the bottom. Finally, I will use the same settings to print the top of the mount with nylon carbon fiber. It started okay, but after a few layers, this carbon fiber filament can't stick to the bed, and I had to stop the print. I tried to lower the nozzle and start the print again, hoping it would stick better, but it still didn't work. As you can see, the bottom of this model only has a small contact surface with the bed, so I think it's safer to use a glue stick. However, I won't use that on a textured surface because it won't be easy to clean up. So, I just flipped it over, applied some glue on the back of the steel sheet, and started the print again. This time, it sticks very well. In fact, it just prints on the thin layer of glue, so no matter what print surface you're using, it should still stick well. Okay. It printed successfully. The glue looks a bit messy, but it's easy to clean on the flat steel surface. The phone mount looks pretty nice. It has a nylon body, a nylon glass fiber knob, and a nylon carbon fiber top. It's very rigid and should be more durable than those off-the-shelf cheap phone mounts. After all these prints, I would say the print quality of this Ender 3 S1 Pro is as good as the Ender 3 S1. They are both outstanding. The Ender 3 S1 series is really a huge step for Creality, as they are no longer producing DIY 3D printers that require a lot of tinkering and upgrades to print well. These are consumer products that work great right out of the box. The new Sprite extruder is working really well. It handled tough models like the Eiffel Tower, which require an excessive amount of retraction. Using the maximum Z height of the printer at 270mm to print the tiny tip of the tower still looks great. These towers are the best I have ever printed using an out-of-the-box printer without any upgrades. The new textured PEI spring steel sheet also works pretty well. It sticks well on most filament, and it should also stick well with nylon carbon fiber, but the tiny contact surface of the model was challenging to print without using some glue. This textured sheet is quite good even when you set the nozzle height a little bit too low. The first layer will be more squished, but sticks well without forming an elephant foot at the bottom. The surface doesn't easily have marks and damage left behind. As you can see, the PEI texture sheet is still brand new, but the sticker sheet on the Ender 3 S1 has some marks. The new LED light is working great. It consumes around just 7 watts per hour, and it's good enough for you to see the print at night without having to turn on other lights in the room. It also has an on and off switch in case you don't need the light. The Ender 3 S1 Pro uses less energy than the S1 and my old Ender 3 Pro, so the insulation under the heated bed did make a difference. In order to print a 3D Benchy, the S1 Pro used 179 watt-hour, the S1 used 203 watt-hour, and my old Ender 3 Pro used 204 watt-hour, which is basically the same as the S1, as they both have no insulation. Keep in mind that the LED light also consumes another 6 watt-hour because I kept it on during the whole print, so the S1 Pro actually saved 17% of power compared to the S1. The assembly is easy, just like the Ender 3 S1. The appearance is even nicer with the redesigned one-piece injection mold base that wraps the 2 side aluminum extrusions. The drawer is also easier to access and has a larger capacity. This printer is almost perfect, but I would still like to suggest some improvements. First, the redesigned UI did include all the features in the Ender 3 S1 or Ender 3 V2 screen. You can adjust Z offset in real time, set the step value of the stepper motors, change the speed, acceleration, junction deviation, and preset the temperature for preheating filament. However, the menu is not organized that well, and you may need to take some time to actually find the features. For example, if I just want to simply preheat PLA, I need to go to the Ready menu. In other Creality printers, this is called Prepare. Then I have to click the Manual tab on top, and here it is. This may not be the best place to put this feature. Another example is, if I want to adjust the Z offset, I need to go to Settings, select Level, select AUX Level, which is supposed to manually level the 4 corners of the bed, and then the Z offset adjustment buttons show up here. Personally, I would rather have the screen UI based on the Ender 3 S1 or Ender 3 V2 and just add extra features under the same structure of the menu. Second, as this printer came with the high temperature hotend, using it to print abrasive filament like nylon carbon fiber or nylon glass fiber should be expected, but this printer didn't come with any hardened steel nozzles. It only came with 2 standard brass nozzles, which will wear out really quickly when used to print abrasive filament. I would suggest that Creality can include some extra hardened steel nozzles with the machine. Finally, there is still no Wi-Fi printing. As the latest top-of-the-line Creality 3D printer, this Ender 3 S1 Pro should include a Wi-Fi module. With a few extra dollars, it can add an ESP32 or even a cheaper ESP8266 module with the Cura plugin that allows you to upload G-code files directly from Cura and start printing, just like how you use an inkjet printer. Creality has a Wi-Fi box that supports the usage of their mobile app to send print jobs to the printer, but that's not how most people would usually print with a 3D printer. In conclusion, this Ender 3 S1 Pro does meet my expectations. The hardware is awesome, the build is solid, and the print quality is amazing. It is based on the already good Ender 3 S1, and it also added a variety of useful upgrades. The 300-degree hot end that can print nylon and other high-temperature filament really brings this printer to the next level. If you are still choosing between the Ender 3 S1, Ender S1 Pro, or other mid-range printers, I would highly recommend this Ender 3 S1 Pro, even though you may not need to print high-temperature filament for now. The price of this printer is close to $500, which is not cheap. But buying a cheaper printer and adding the features that came with the Ender 3 S1 Pro afterwards would cost you even more, like my old $200 Ender 3 Pro, where I spent more than $300 and countless hours to add many upgrades last year. I recently added a $90 motherboard and a touchscreen, so I am quite happy with all the upgrades, but it is still not as good as the Ender 3 S1 Pro. I have another review video for the Ender 3 S1 that goes into more detail, and I put the video link under the description. If you're interested in the S1 Pro, I also put the link down below. That's it for this video. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week.